Algebra 2A, red class. Today's Monday, April the 3rd, brand new month. And so, what's the first problem I want you guys to attempt to do? All right, so I'm going to say what the first thing is that we would do to do this problem. Very nice. Plug that 8 in. Put that 8 in over here so that way you see it there. We'll take someone different. What's the next step that we might do? For a little back. Alright. You're back in the pool just in case you happen to know the second step. We're going to divide. In other words, we've got to get that log x alone. And these problems aren't very difficult. It's just remembering the steps. If you remember the steps, then you're just doing it. But the only thing that can stop you on these are just, hey, shoot, I forgot the steps. Log x. Someone say out loud, what's that? 8 divided by negative 4. Okay. Alright, it is negative 2. If you didn't do it, you can write down the steps. So once the teacher starts writing on the board, you don't have to so you can get it. No, I want you to have it. Anytime a teacher puts something on the board, usually they want you to have it, otherwise why didn't put it on the board? Somewhat different, and then I may use David as backup. Anybody know what the base is when there's no base written on that log? 10, very nice. Alright, 10 is that base that's there. Some people think it's a 1, some people think it's a 0, but it's actually a 10 there. And then the next thing, the question is, what is that phrase to write this in exponential form? What's that phrase? I got the switch part, but there's another word that comes before that switch. Base and switch. In other words, rewrite that 10, which is the base. How can you tell? How can you tell it's the base? There's a way to tell it's the base. I'll take the bottom part, not necessarily the smaller, but it's always lower than everything else. The base is always lower. So here comes the base and a switch, the 2. And the switch, for those who haven't been here, is switching sides the equal sign. You switch there. So let's see if we can get this one in. Where are you? The equal sign was here. The x was over there, so you switch. And the negative 2. Base and switch. This is what's the word I'm looking for? This is a standard 3 problem. Some people missed it. And when you check yours, I put a check mark next to the points that you got, or the score. Did I get a 1, a 2, a 3? And then the last move, we just punch this into the calculator. 10 raised to the negative power. This one, I want to actually come around the room and see, even if you didn't do all the work. The question is, can you punch in 10 raised to the negative 2 power? Because let's say you're super getting all the steps, but you can't punch that thing in, and it messes up. What will that give us, though? 10 to the negative 2. Say it again one more time. 0.01. This one I'm going to come around and look. I'm not putting a check mark, but I just want to see, hey, in your calculator, I want to see your calculator, this thing put in there. Second one from standard 1. This one here can be a little bit tricky. This is one that some people could have missed. This type of problem. I'm still going to put it up because, again, it's just steps. If you know the steps, then it won't be the hardest thing in the world. It's kind of then this problem may not be that bad. Let's take a look at it and see what happens. Guess along with me. Can someone guess what the first things we do on this problem? Say it again. Divide the 13, and then we'll give someone else a chance. So good start because we want that E. I made the E in red on purpose. So we divide the 13 on both sides. With calculator, what does this 130 divided by 13 give me? And if someone can punch it in now if you haven't already. That is a tricky one on the calculator to type in 130 divided by 13. But if you do it and say it out loud to me, that'll be a big help to me. Again, I heard it. 10. What I hope you will feel as I go through this one is none of that stuff is hard. I just didn't remember all of those steps. And that is true with math. Math is memory. You remember the steps, you're good at math. You forget the steps, you're not good at math. So if ever you thought or someone told you, yeah, you're just not good at math, you don't have the thing that it takes, no, no, no. I remember the steps. I do them. I get 100% on my test. I forget the steps. I get 50%. That's enough. Okay. But it's all about memory. So if ever you want to be better in math, let's say you decide one day, I'm going to do it. You go to the part of the library or internet that's how to improve my memory. And then they're going to tell you stuff about turning things into pictures in your mind and different little lists. But once you have it, believe me, your scores in math and really all your subjects are going to increase just because your memory is better. Anyone know the second thing that we're going to do? Yeah, that was the tricky part here. I can't remember the second thing. Anybody remember the second thing? Now we take a guess. Guesses. The natural log is going to show up. In other words, we're trying to get to t. T is floating up in the sky. To get to something up high, the tool that we use is log. Because e is here, here's what it's going to look like. You're going to divide e on both sides. But the e has to use what David just said, which is natural log. In other words, we usually put log when we're doing smooth. That's when we're doing ln. Now, type this in your calculator. Where's that LN button? Is it right below? Okay, right to the left of the of 4, number 4. So type that in right now. And everybody, I want you to do this, even if this one is going to be tricky for you. Type in that LN of 10. Close that parenthesis. I think this is important. Divided by LN of E, and then close that parenthesis. Oh, where's the E? Isn't there an E in there somewhere? And so some LNEs. So here it comes. What was, and I didn't look at the answer, what was natural log 10, which is what LN stands for those who have heard it. Why they reversed it? Why didn't they do NL? I don't know. I wonder why they didn't do that. Maybe it's sometimes in Latin the letters are switched, so maybe they did that. In any case, what does natural log 10 divided by natural log E equal? I heard 7.30. 2.30. All right. And we're left on this side. Now, just so that, and I keep saying this, but then I keep showing you the wrong way. Officially, and I'm just going to put it for a second so that you'll have heard it that way. If you're supposed to say, you're going, no, you're not supposed to put that there. Don't go to the left side. Technically, the LN also goes on the side of the E's. I'm not putting it in because I don't want to add extra steps and then make it even more that students remember, but just so that you hear a teacher do the official way. And I'm going to write it in, then I'm going to erase it. Technically, there should have been LN here and an LN here. And what happens with this natural log? This natural log is sort of like a ladder or like a staircase. Everything that's floating up here on the roof of the house, it can step right down in front of it. In other words, all the stuff here comes down, and then the LNs disappear. Well, Thomas could have done all of that, and it's hard enough already for students to remember all the stuff, so I didn't. But I want you to know that in some of the math, you put this E down here like this, and this one over here, then you put the LNs over here, but you didn't do anything over here, that teacher may give you a hard time. Say, aren't you forgetting something? You're like, I think so. But just be aware of that. For me, since I'm teaching it to you this way, I'm okay with it. And now you're left with the regular old. To get E alone, it's a 0.23 times T. I divide on both sides. You know? Some people miss this one. Some people aren't even sure how to start it. Today, when you get your assessment back, you may check this problem that's similar to this one and be like, oh, shoot, I could do that one. If you have a 2 in that section, of course, it's not required. If you have a 1, is where you fix it. 2s usually don't go up, at least as I do it. Just saying. Alright, so what are you doing, Thomas? You're dividing this last one over here. And we'll find out what that thing actually equals. Alright, this is old stuff. I feel like I'll get this a little bit while on old stuff. But then again, what some of you haven't forgotten, and I'm kind of happy I did it, so I'm half and half. That's what I'm also with this school in terms of classes. Twice a week, 2-hour blocks, Monday, Wednesdays, and then from Wednesday to Monday, How will the student remember all that stuff? That's a long time. There's no homework for you to do that. Um, this is that. 2.30 divided by 0.23. What does it come out to? I appreciate that. Thank you. Take a look and see. There are a number of places for a teacher to mess with, make it confusing. So here I go. One. With your pencil, go ahead and circle exponential. This is an exponential function. Can anyone say out loud how you can tell by looking at the equation? It's an exponential function. It has an exponent. That can be true. That can be true. Let me go with her answer and say, not only does it have an exponent, but it has a letter x in the exponent. If x is in the exponent, then it is an exponential function. Here is a function that is not an exponential function, but it has an exponent. Let's say y equals 4. Let's say 4x raised to the third power. Hey, there's an exponent, there's a 3, he's all floating up there. But because x isn't up there, it's not an exponential function. Okay. So this is an exponential function. How do I know? The x is in the exponent. I'll put x is in the exponent. And you can write that too. X is in the exponent. That's how you know it's an exponential. Write that down because you have it there just in case they ask you that. All right. So let's start with easy one. Draw graph. Draw graph. How do I write that? And they already asked for the end behavior. So let's see if I can do these 2 pieces of 3. Draw graph of this thing here. Draw graph. Yes. Hey Thomas, is this easy, hard, or in between? Oh, we find out. No. Say you had to do this already. Thumbs up. This is easy. Sideways in between. Thumbs down. This is going to be pretty tough. Show me thumbs up so far for you. Easy, hard, or in between? Rather easy, hard, in between. All right. I see some in-betweeners. I see some thumbs down, which I would expect the thumbs down because I would expect you don't know how to draw it, but watch me. Airplane. It's taking off, taking off, taking off, taking off, and up. There it is. Look how easy that is. Draw that picture. I don't even mean anything to you. And some math people be mad at me just doing it this way, but I'm going to do it easy. Eventually I'll fix it, make it hard so that you be mad and take math all over again. But right now on the assessment, you need to draw a picture. There you go. Okay. There's some other pieces to this puzzle. Where it goes through, now that's a random place here. It looks like it's on number 2, but it's random right now. What is the name of this random place that eventually we're going to give a name? We're going to call it the letter A. That dot right there that it goes through the breaks of the wall, that's the letter A. Let me make that A a little bit harder. Let me make the A a little bit harder just for a second. The coordinate form of that letter A will be 0, A. That's the one they're going to want. So I'm going to tell you what A is first. And once you know what A is, then from there, you can put in coordinate form 0, whatever number he gave us. So step 1, please draw this. It's nice and easy. It's an airplane taking off, and it goes through and it breaks through it. No big deal. Let me see if I can find another one of these where you can draw the picture. Yeah. Go to page 11, and please draw the graph that goes with problem 11. The question is, first, what type of function is number 11? Oh, They tell us an exponential. Now, let me try this. How can we tell, even though there's a fraction here, how can we tell this is an exponential function? Do it again. The x is in the exponent. So no matter who the base is, in this case the base is 1/3, go ahead and draw the picture. For those who may be wondering, get a hint. Yeah, it looks exactly like the picture. Hopefully that hint isn't too strong. So draw that in. The beauty is the picture for an exponential function, no matter what the base, is exactly the same. At least that's how I'm going to present it to you. Alright. Here it comes. On this one, let me come around and check mark it since I expect everyone to have this one correct. Why not get a check mark? Will it get harder? Yeah, it will. But I just want you to start off nice and easy. Draw the picture of an exponential function. There I go. It always goes through the wall at A. Eventually, they'll ask to write the coordinates of that A. It's A, so we can start making it math-like. Let me ask, somebody might remember this from algebra. When a line, a graph, hits the y-axis, the point where it hits it is called something. I heard y-intercept, and I saw it back there. This is officially called the y-intercept. Where you hit the y-axis, it's called the y-intercept. So eventually they're going to ask you for the y-intercept. All right. So we got that one. Do me a favor, back up to that original picture. It was on that other page with 3. How do we draw their picture or extend their airplane? What was that? It was page 4 was the original. There it is. Now their airplane is crashed into the ground, and that's the problem. So kind of bend that out. What page is this? This is page 4. Go to page 4 and kind of bend out the airplane, but don't let it touch the x-axis. If it touches the x-axis, there's a problem. As a matter of fact, I'm going to give you the name of the x-axis in this case. And you'll have to remember this word. I'm going to try and create a picture in your brain now. Again, you can bend it. I'm going to bend mine so it looks like it was done properly. Let me try and go through where they went through on their y. Oh. Okay, it's mine. You know that. All right. Let's get my thing to go with theirs. You can't erase yours. That's fine. All right, let's give them a new word so they can draw an airplane fine. They know it goes through the A. They know they have to write the A as an ordered pair. So far, so good, no big deal. Next thing I want to tell them is what the name of this X line is for this type of picture. The ground that your airplane is taking off from or landing on has the actual name. Anybody know the name of a line that a graph approaches, but it never touches? The name of the line that a graph, this red line approaches, but it never touches. If it touched it, yes, it would be the x-intercept, but it's a line that it never touches. All right. Let me put it in a story form so that will stick with your brain, hopefully forever. Then we'll write the name on it. So there's a party going on. Someone's out there. And some people know that, let's see if I can adjust the music so that the concept is there. Let's see, will it go, will it go? I got rid of them all, fine. Yeah. Come on. Yeah, we'll do this one for the purposes of this. Yo, what's up? I mean, the point. All right. So this has to do with this line. This is my effort to put in your brain forever. You at the party or whatever. Now, some of you know, at parties, and this one, I'm happy I don't have a daughter, the music can mess with their mind, right? The outfit is the wrong outfit. Yeah, I shouldn't be wearing that. You snuck out wearing something different. By the way, it's about a math problem. Let's go with it anyway. And so so you walk in the thing, and everybody, you know, on the wall, and then she comes do her thing. Yeah, you shouldn't do this. I'm glad I don't have a daughter. She comes do her thing, and then whoa, whoa, is this recording? Oh, I can't hear. Whatever. All right, so it's about this line, by the way. And so she's doing her thing. He's a supervisor, and so the guy come out. He's doing his thing. And he got the hand, and she's doing her thing, and then just so he's about to, and like, no, but then she stops, freeze, right there, and she says, don't touch the acid. What's the name of this line? You come close to, but do not touch. Yeah, you're right. It's called an asymptote. Should write down this. That's my my story for that. All right. So this line here is called an asymptote. This line right here is called an asymptote. Now on your test, let's see if we can go back to learning music again. All right. Where are you? All right. All right. Why it's called an asymptote? The actual line. I'm not sure. I know why it's called that at the party, but here at the line, an asymptote. The official definition of an asymptote is the line that a graph approaches but never touches. So we're going to write down that definition just one time so you have it there. Asymptote. A line that a graph. Sometimes I call it a graph a function, but I'll call it a graph so you know it's the picture. The x and y axes are not the graph. They're lines that a graph approaches. But never touches. Write that down. On all of those pictures that you're writing, you have an asymptote in all three of them. Where the airplane is taking off from, technically it's taking off from the asymptote. Even in real life, it couldn't do that because it'd have to be floating above the ground and taking off. But for my purposes, that'll do. So they can draw the picture. They need to find out what the A is on their picture now. All right, let's get the A on their picture. Well, first of all, they know that A even exists. Let's see if we can get this in here. All right, step 2. Let's see if we can get the A. Every exponential function has a model that it what's the word I'm looking for, that it is formed after. In other words, there's the letter Y. There's the letter Y. There's the letter A, which is always right in front of whatever is B. Let me see that BX in green so they can feel this, or even in blue. B to the X. So all three of those that we went to and we did the work on them, they all have these 4 pieces of the puzzle. They got a Y. You don't care, by the way. You don't do anything with the Y. They got an X. You don't have to do anything with the X. You do have to do something with the B and the A. The easiest of these 2 to figure out first is the B. Why the B? The B is the person who's holding on to the X. So if ever they say, in this equation, please identify the B, the base. The base is always at the bottom of an exponent. Okay. My base is 3. No big deal. I got my B. The question is, what is my A? Because once I know the A, I know technically where the airplane flew through the wall. Anybody know what number is? I don't know how to say it. Maybe we did last time. Anybody know what number's in front of that 3? Let's be multiplied by a number. Yeah, that's the 1. I think we did it last time. Now the good news will be this. If ever they give you one of these simple equations where it's just a base and an X, the A will always be a 1. It will always be a 1. The only time it's not a 1 is if they give you a different number. Like if they put a 2 in front of the 3, oh, then you know it's a 2. If they put a 7 in front of the 3, oh, you know it's a 7. The only time it will not be a 1 is when it is a, what's the word for one? It's another number they give you. Okay, so Tom, what are you telling me? You're telling me when they ask you for the y-intercept, where the airplane breaks through the wall, for this problem here, it's going to be a 1. How are they going to write that one? Where are we going to write this one? I'm out of space. I'm going to try and write the one right below the A. And up here, I'm going to put it right in here, 0, comma 1. Take a look at that, see if you're confused. You get to do it 2 more times. The good news for you is the version that you'll be doing today for assessment purposes, they'll actually give you that other one. So you don't have to worry about the one. But we'll do the one part first because the one is the most famous. All right, what's that other page where now they need to go back and find out what their A is and write it in coordinate form? And so what was the other page? Let's see. We did, that was page 4. You go to page 10, and please, we're going to try to identify what the one is, and then I'll do one other one without you. Right out there. Let's see, there it is. So again, let's see, if I write below here, this one I'll ask out loud, so some student who gets it can already start saying it. Can someone tell me what the A will be in this problem? Yeah, it'll be 1. If they don't put it in, now some of you may already get like, okay, why wouldn't they just write in the 1 so that we can see it? We see that all 4 pieces, the Y equals O. I wrote the stage file below, but I wanted to write ABX. The reason they don't write it is since it's understood, why have to write it every single time? Let's see if I can put in the actual form of the 4. Alright, so it's not going to do it. We'll go ahead and label it on your picture. That way if they ask you what is the y-intercept of this problem, the y-intercept is your A. Come on. Alright, so right now this should feel pretty good. I'm going to have them go to another page while I finish writing mine in. I just want to write in the ABX. Hey Thomas, why do you want to write in the ABX so that when students see the equation y equals ABX, they know what they're asking them for, and they know they already can find it. Most of it, they give it to them, and the other guy, the one, will be there waiting for them. A is the y-intercept, so let's do that this time. A, put y-intercept. Write down that A is the y-intercept. I'm writing it that way. Hopefully that doesn't look confusing. Hopefully you can feel what I'm doing. Starting off easy. Oh, I draw an airplane. Hey, there's an A. Now I'm using some of the words that they use for it. Because if I start at the beginning, make sure you draw the graph and write down the y-intercept also. Some math people, non-math people, they're like, fine. Alright, so let's see. In this case, we got another 1. Let's see if we can do one where it isn't a 1. No, there's one more that's a 1. But now let's do a fraction so it can scare somebody. Alright, yeah. Now I like it. Alright, go to page 11. 11. Alright, fill in 11. Put in what the A is. And write in coordinate form 11. It's a fraction, but hopefully it doesn't scare you. The base is always connected to the X. I'll ask out loud. Can someone say out loud what the A is going to be? Still 1. Like that fraction throwing them off. They just didn't create the space in here. There's still a 1. How can you tell it's a 1, or how can she tell? Whoever's connected to the X, you're automatically the B, even if you're a fraction. Okay? The Y, you're still Y, so the only thing that's missing is that number that's not there, and so in this case, it's a 1. Alright, let's see if the first time they switch it up on them doesn't mess them up. There's a 1, 0, comma 1. Alright. Please, on the next page, draw the picture. Still an exponential function because x is an exponent. And then put in the A, the O, comma A, and then determine what the A will be on this one. If you want, you could write the formula directly below the equation, and that might help you decide who's going to be A this time. This is the first time it's going to be different, and this is the kind of problem that you might get on an assessment. So again, do me a favor, and I guess I definitely want you to draw the picture, but below the equation, put in your y equals ABX. So that way I know. This one I'm going to come and check mark. I want to come on and check mark the y equals ABX. That way I can tell, do they put the A below the correct answer? So what is Thomas about to come around in about 30 seconds and check mark? On this page, which is page 12, put in the y plus abx. So they can find that. If you get this one right, that means you're ready for the second piece of the puzzle. This is the first piece. Can you draw it? Can you label it? Airplane taking off. Can I put my y equals abx? I'm coming around to check. Alright, here I draw the airplane, then I put in the number after. So again, I'm still drawing it. Start my asymptote, and I just go up. Now, if we did this the way we've been doing it, there's my A, my 0, comma A, which is how I write the coordinate form of it. Can someone say what the A will be in this problem? The 0, comma 10 is the coordinate. I'm going to put my 10 below that A over there just to show that how do I know that's the A? There's only two pieces of the puzzle. You're connected to the X, so you have to be B. And this guy right here, he's A. Let me call it simply any question. They can draw an airplane. If you're given an equation, step 3, you have to make your own equation. For now, let's go step 2. Here it comes. They want end behavior. Where there it is. Circle end behavior. All right, come on. We can do this thing. End behavior. Here's a red line. It's a graph. If I were to chop this graph in half, let's say what's to the right of the y line and what's to the left. Okay, that's chopping it in half. Let's say that. The end behavior is, can you look at this red line and determine as I go this direction, which we'll call x, what is the red line doing? Is it going up or is it going down? Oh, let's get out loud. Hey, is the red line going up or is it going down? That's going up. So it's not supposed to be tricky. When we have to translate into math talk, that's where students miss it. So put in arrows. What is this red line doing as I go to the right? Yeah, it's going up. It's not big deal. How do we write that in math talk? Oh, wish me luck. Here it comes. For end behavior, I want you to write end behavior over here. End behavior. I know it's in the sentence right over here because we're about to write part of the answer that they're going to require of you. Thomas, please write down the end behavior. Here it comes. This right arrow, let's see if I can do it right. This line is the x-axis. So when I talk about going left or right, I'm talking about an x. As x goes to the right, that's called positive infinity when you go in a direction. All the way this way, I'm going to positive infinity. I'm just going, I'm going, I'm going. If this wall wasn't here, I just keep going forever and forever. I'm going to positive infinity. Okay? Infinity isn't a number, it's a direction. Okay? So as x goes to positive infinity, going up and down is called y. What is y going to? Well, if you go up, 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 positive, I wish I could float that. Sweet, they'd be all like, "Wow, that was floating." Oh man, I can't. But if I could, if I had those powers, I'd float it to the ceiling. I've had a dream where I could fly, and it's all right. But, it's also going to positive infinity. So I'm actually going to put these infinities at the end. I've never put the infinities. I don't know why I've never put the infinities. Why haven't I put the infinities in the past? That's so weird. This is my first time putting the infinities. Maybe that would have helped out students. Alright, so again, as x goes to the right, we're going to talk about this half. Now it goes positive. By the way, if that was easy for you, that's the way they're going to ask you. So it's not going to be, there's no new thing after that. Here comes the part that messes up some students. What happens as x, as we travel towards negative infinity? Should I put it below it? Right. Below it. If I had space, I'd put it below it. Sometimes I'll put it right next door to it. Fine, I'll put it on this side. Alright. As x goes this direction, here's why it's tricky. See how I have to write this arrow to the right? Some students see this arrow coming to the left, and they're like, on the picture, it tells me what's happening on the picture, but when we write it, all the arrows point to the right to say, as we travel this direction is called negative infinity. If I go this way, it'd be negative infinity. If I could get through this wall, it'd be negative infinity. I'm only getting it because it's early in the morning. I'd be surprised. It wakes some people up or whatever, like, what is he doing? Which is part of my teaching style. Like has nothing to do with math, just waking somebody up. As x goes to negative infinity, first trick problem, get the brain ready. Is the red line going up or going down? It is going down. Now here's the bad news. There's a big asymptote right here, and as a result, it can't touch the asymptote. It can't go below the asymptote. The best that it can do is approach it. Now this line, let me put in the number and explain why it's a number. Y goes to 0. Where did we get the 0 from? Let me see if I can point this arrow down here. On the Y line, you don't have to write these numbers, I'm just showing you. This would be 0, this would be, not 0, that would be 1, 2, 3. Alright. This would be 0, this would be 1, this would be 2, this would be negative 1, negative 2. Okay. If I'm on the Y line, when I'm coming down the Y line, I come to 4, 3, 2, 1, 0. This line is 0. The airplane is approaching 0. It won't touch it, but that's what it's approaching. Going this way, it goes up and up forever and ever. Backing up, it comes down, but it'll never hit that asymptote. It'll keep coming closer and closer, but it'll never hit it. Take a look and see if you're okay with that. You're about to do this 2 more times on all your other pictures. The good news is the pictures are all the same. It's an airplane taking off. So the green stuff, the right-hand side, yes, it will be x goes to infinity. And as x goes to the right, y also goes up forever. Same thing, as you back up to the left, because it's the same airplane picture, y is going to 0. It's going to the asymptote. What do I want them to do? I want them on page 12. Oh, this was page 12. I want them to back up then to page 11. And please write down the end behavior for that picture. If you need help, it'll be exactly the same as on page 12. It's not going to be the same as if the numbers are different. Numbers are different, yes, but the picture's exactly the same. It's an airplane taking off. So what I want you to do on that page, please draw the arrows on the actual picture. I wish you had different colors too. Put in the end behavior mark. I'll come and check mark this one. For the green stuff, as x goes to the right, y goes straight up. So what comes after the y? Y goes to what, someone? Thank you. Someone different. On the blues, as x goes to the negative infinity, that is, it just means it goes to the left. This is math talk for going to the left. What does y go to someone different? Yeah. Look at it. See, I'm about to leave this part. The last section, now I'm going to create, make an equation, draw a picture, and behavior. So we did the last 2 pieces. Alright, which is left. Last part, they're going to give us a paragraph. We have to decide who's the A and who's the B. Who's the A, who's the B? On this one here, actually before I do that,
how do we answer this question, or just explain what it tells someone that would be correct?
For this one, nothing for now. That will probably come as part of this last segment. So hold on that. It has to do with what A really is and what B really is, which is what we're about to look at. So a good question. I'm doing it out of order, so let's see if that part will come up. If it doesn't get answered, do raise your hand again and say, hey, I don't think you answered that part. All right, so do me a favor, go to, so that you can have it in. By the way, it's writing these in, even though it's a little bit of stuff. These we will probably be able to use X6 pages. But remember, there's some parts where you're not doing so. Of course, you got to get those parts in. Go to page 4 and write in the end behavior page 4. A little time. What's on page 7? This frog is on 7. This is page 7 right here, yes? That's page 5. So go over 1, 2. All right, let's start. You get used to that using your words, but the words being obvious. Back up. Go to page 4. Let me mark some words on here too. Page 4. Let me mark some words on here so that when you hear them in the actual problem, it'll make sense. Your A. Is it going to be like that? I don't know how you're going to mark this, where your space can be. A is the initial amount. I don't know how I'm going to mark mine. Alright, so I'll just do this. Or I could just write A over here. A, initial amount. Hey Thomas, why is that going to be important? Because they're going to give you a big paragraph, and you have to write out an equation. Y equals ABX. They're going to give you numbers, and you have to decide, okay, well, which number is going to be my A? Well, in the little story, you always start off with a certain amount of something. Start off with 10 frogs, or 20 this, or $50,000 that. Your initial amount, that's your A. The B is going to be called, is the growth rate. How much is that increasing now? The frogs are doubling every month. Your money in the bank, that thing is going up by 5%. Whatever it's moving up. Now, here's the good news. If you find your A, there are only 2 numbers. So if it's not A, then it's going to be the B. But the B is what's called the growth rate. This is the last part of the puzzle before you get a chance to do a few of them and then put it all together for standard 2. The growth rate. All right. Growth rate. In this case, this thing is tripling. Whatever. I start off with $1, but that thing is tripling, like times 3. Like so, the next time they checked on it, it's times 3. Now I got $3. Then the next time they checked on it, multiply that by 3. Now I got $9. Next time they check on it, I multiply by 3 again. Boom! I got 27. So that thing is like exponentially growing. Linear growth, you just add $3, add $3, add $3. Exponential is what you want, because it like multiplies the thing you just had. But then that new thing, you multiply that new thing by the same number by 3. The next new thing, you multiply that. You don't just keep going back to the beginning. All right, Tom, so like, what are you even talking about? Page 7 is this guy here. Let's start reading so you can hear how they start saying it. We're just going to label the A and the B. So this is page, am I on page 7? And the reason I have to ask this again, I don't have page 7 on here on this board. I just shows. Let's see if we can mark some stuff here. I wish you had a highlighter. You could highlight it better. It says here, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2 to the x power gives the population after x weeks. How many beetles will there be after 56 weeks? That's a lot of information. Does Thomas want you to know all of that? No. Here's what Thomas wants you to know. How many beetles did we start out with? Anybody see how many we start out with? 30. I put my A here, or since I actually put it in the function form, put my A here. To say that they're doubling every week, it's 2 to a power. To say it's tripling is 3x. Quadrupling, 4x. Okay. Oh, it's going up by 5%, 5x. But the number that you start out with, that's the key. Once I have that, automatically, the second guy is my B. Now, they're not going to give you the whole formula. It's going to be your job to just get the paragraph above and put that 30 first, put that 2 second with an X on it. You're a winner. All right, let's see if we can find another one of these that they do that. Try to read this frog thing. Do write down the formula y equals ABX. I'm writing mine here. You might read right here below. What are they talking about? Where did it start. Because once I know where it started, I got my A, and the B is the other number. So read that. Now you can see these two. This becomes tricky. I try as much as possible not to make math talk, but at least do the motions. Which some math teacher will ask it from you in math talk. The other thing I hope you can feel is try to be present as if you're absent. I'm kind of watching some video, but it's not quite the same. Certainly the asymptote stories that won't be the same. Alright, look around and mark that you're here so that you can see that you got it right. We have our A and our B, of course. Why it's slowing down, I don't know. I'll try. Alright, I don't know what page that is, but that's another one where they just give it to you. Alright, so draw an airplane. We know A was a 10. 0, 10. Our X as X. I'm going to be green. I'm going to do the colors. Whoa. I don't want that to have to, whatever. As we go to the right, the picture goes up. As we go to the left, the picture is stopped at 0. I saw this on your paper. The end behavior would probably be one of the easier things. Go to infinity. Y also goes to infinity. Goes up. And I'll put it down here as X goes to negative infinity. Y goes to 0. Okay. That's it. Let's give you the harder version of it, but that's the 3 pieces I want to give you today. All right, let's see. Harder. Where does it start getting harder? They could draw the picture there. No. All right, let's mess around with this. All right. Go to page 15. Try to read. This is just about as close as it can get to what you'll need to do. Read it. Put in your go with it. All right. I'll read out loud and then we'll choose. Since 2005, the amount of money spent at restaurants in the U.S. has increased by 7% each year. In 2005, about 360 billion was spent at restaurants. Oh yeah, it's a little bit involved. Can someone tell me what the initial amount was? That 360. And the way you can kind of tell, usually with these with percents and money, usually it's going to be the money amount. You just got to figure out where it began. The fact that it said this is how much it increased, that kind of tells you how much did it grow. How much it grows is kind of that B, the growth factor. So that 7% growth factor. Y equals a dx. So when I put that thing in, I got my Y, I got my 360, and then I got that, I guess I could leave that out of parentheses. I got that 7. That 7%, which I'm going to fix. It's going to be broken. That's going to be that last part that tells you, oh, this something needs to be fixed. So I'm going to put it in this way just so they can tell, okay, I got my pieces. Draw my picture. Airplane, no big deal. There's my 360. My end behavior started off some people's pages. It's the same airplane. It's for numbers because an exponential function is always graphed exactly the same way. Okay. You get one last chance with this thing. Here it comes. Normally the green. By putting in your arrows, when I see that, I know what you meant. So if it's wrong, I can at least go, okay, well, your arrows are telling me something. For the green, x goes to infinity, y goes to positive infinity. We're down to the last one of these. And then for the blues, as x goes to negative infinity, y goes to negative infinity. Oh, I'm sorry, y goes to 0. Look at it. Fix what you might need to fix. There's a piece we're all going to have to fix in just a second. And then when you do it the last time, now without the fixing. Alright. Here's a piece that's broken on everybody's page. This 7% can't just be written as 7%. There are two things that we have to do. One, we have to change the percent into a decimal. And for these problems of increase, there's a certain extra move. We have to add 1 to the number. So I'm going to turn it to percent, and then I'm going to put a 1 in front of it. You'll see what I mean? So that the next one you get, you'll turn your percent into a decimal, and put a 1 in front of it. This is the last tricky part. Everything else is fine. Here's what it looks like. This part everyone needs to do. So we change this percent into a decimal. Cross out, find the decimal point. 1, 2. You only move it 2 times to decimal. Everyone has to do this because no one would have done it. Someone with a 0.07. That's the way it has to be written. You can't use percent in the problem. So that's wrong. That's illegal. I just wanted to do it so everyone had it. And here's the other piece. Because this is increasing, it's a growth problem, there has to be a 1 that's put in front of that. 1.07. It's a rule, it's a step. Eventually I might flesh it out, but that's the deal. So technically what should be in here, hopefully you can write it down. Technically in here should be a 1.07. Everything else is the same. If your brain is burned out, I'm going to have you do one more, and I'm going to give you the assessment. At the very least, the idea is, okay, they'll be able to get some of it in. They can get their A. They can get their A. That's no big deal. Yeah, what if it's broken on that percent part? When it's time for them to fix, I can say, hey, look back at your notes. What did we do with the percent? Yeah. All right. So what does it need to do? Number 16 is almost the exact same thing. The only difference is they wrote the word decrease. Cross that and put increase. That way it's the same. No problem. This is it. After you try this last one out, everything's going to be right. Fix. In 5 minutes, which means you'll probably only get a chance to do standard 2, and you can peek at maybe one problem in standard 3 or 4 if your brain is dead, but this is it. This is why I was nervous. It takes a lot of brain power to put it all together. What is it talking about? What is that thing again? Not sure again. We're doing extra numbers. That's giving you enough time to be able to get one problem. Again, those were your earlier. You'll also be able to peek at the score you got on your standard 3 and standard 1. Just to try one of those. All right, here it comes. Can anybody guess what the A would be on this one? Got a bunch of numbers. Well, let me try it. What would the B be on this one? 11, that's it. So that one, that's nice. We move it over. So it's 0.15. We got to turn it to a decimal. Well, let me do it this way. Let me write it here. That way, some people feel good that they took the 11.5%. You feel good. Okay, I chose the right number. But again, we know for these, if it's a percent, we can't use it as a percent. We have to turn it into a decimal by moving 2 places to the left. Always only 2 places. What are we going to add in front of that? That 0.115. You have to add a 1 there. There's a reason for it, which hasn't been fully explained. All right, up there, what do we think the A is going to be? It turns out it's going to be the 101. That 1,000 in there. Now, shoot, they put a 3,000 in there. It's hard to know which one it is. But it says here the atmospheric pressure at sea level is 101. For every 1,000 increase in altitude, then the pressure changes. Again, for your test purposes, it'll be straightforward. It won't have all the numbers floating around. So that's going to be helpful. The good news is, once you have your 101, go on an airplane. Can someone say what the y-intercept is going to be on this one? Go ahead, say it again. But of course, you have to write in the ordered pair. The x and y, they're doing the same thing on this one. I'm about to get your test in a moment. Check and see if there's a question you might have about to say. Are there any final questions? But by the way, with these infinity things, there is a version where it does a little something different. Fortunately, for the purposes of today, you get the same version.